Okay, hey, back again. Hello, hello. Okay, so here we're going to tackle the second kind of advanced arithmetic sequence problem today. And that is this situation where, we'll call this example 1 of this video here. We're given the third term is 18 and the sixth term is 33. Okay, that's all we know. We know it's an arithmetic sequence, and we're given that the third term is 18 and the sixth term is 33. And we're supposed to calculate, just based on those two numbers, knowing those two numbers, what the first term of the sequence is, what the common difference of the sequence is, and what a general formula for the sequence would be. Okay? Now, it turns out that this is pretty similar to, conceptually, the first set of problems we did where we were inserting arithmetic means, right? And in the same way, we're going to kind of come up with a general formula for calculating what the common difference is, because that'll be our first step, is to calculate the common difference, because we can kind of visualize the problem like this. If we've got the third term is 18 and the sixth term is 33, there must be two terms between them that are the fourth and the fifth, right? And you have to be adding three numbers in between. So what we're going to do is we're going to calculate it like this. I'm going to put some formulas and procedures over here for this kind of problem. That D is going to be equal to the sequence difference. That is the difference between the subsequent, the upper number, minus the lower number, how far we're spanning, minus the position difference, right? That is how far apart the two position numbers are, from sixth term down to third term. And this is actually, although we're writing it a different way, very similar to what we did to insert the geometric means. It just looks a little bit different here. Okay, so here we're going from 18 up to 33. So I'm going to put that over here. Actually, D is equal to 33 minus 18. And then divided by the position difference, we're going from the third term up to the sixth term, so it's going to be 6 minus 3, right? That's 33 minus 18, right? 33 minus 18, that's 15, of course, right? So that's 15, and this is 3. So that tells us that the common difference is 5. To get from here to here, we have to be adding 5 3 times, right? So D is going to be equal to 5. Now, if we wanted to, we could think about it this way, because we could say, well, 18 is the fifth term, 18 is the third term, so we could subtract 5 and get 13 for the second term, and subtract 5 again and get 8 for the first term, right? So we would know that a sub 1 is 8. But sometimes, on some of our problems, that's going to be kind of awkward, because as you will see, won't always be the easiest way to do it. So I'm going to show you a more general way to do this, okay, to figure out what a sub 1 is. So now we've got D, you understand, is 5. Let's put that there. What's a sub 1? Well, if we know that, and it doesn't matter which two we use, if we know that the third term is 18, so this was part 1. Part 2, we're going to use this formula here. I better write it down so you know where we're going to start with. We know that this formula here is the general formula for the entire sequence, right? And we've already just figured out D. And we already have two prospective n's and a sub n's. For example, we know that if n is equal to 3, since 18 is the third term, whenever n is equal to 3, for our formula for this sequence, a sub n would work out to be 18. So I'm going to go ahead, and I'm going to plunk those in. I'm going to say 18 is equal to a sub 1 plus 3 minus 1 times 5. We could also use 33 for a sub 6, and then put 6 in here for n instead of 3, and that we'd get the same answer. Okay? So now we solve backward for a1. So that's 18 is equal to, that's a 2 there, so that's a sub 1 plus 10, right? Because 3 minus 1 is 2, times 5 is 10, subtract 10 from both sides, a sub 1, oh, there it is, it's equal to 8, which is what we got before, right? So this is, so now we know a sub 1 is 8, and that's going to give us our general formula for the sequence here. A sub n is equal to 8 plus n minus 1 times 5. Now that's the formula right there, but we're going to simplify it by multiplying the 5n to get rid of the parentheses. It's 5n minus 5. Combine the 8 minus 5 is 3. So here's our general formula, 5n plus 3. And if we do this right, we'll always come up with a linear style equation here at the end. So that means a sub n is 5n plus 3. We can check our work. Put 3 in. 5 times 3 is 15. Plus 3 is 18. Yep, that gives us 18 the third term. Put 6 in here. 5 times 6 is 30. Plus 3 is 33. Yep, that gives us the 33 the sixth term. Okay, very good. So that's example 1. So let's try another one. Okay, so let's say that I happen to know, so this is going to be example 2. I happen to know that in a given arithmetic sequence, the 15th term is equal to 46, and the 22nd term is equal to 67. So again, we want to know what's a sub 1, what's the common difference, and then what would a sub n, what would a general formula be? Well, step 1, first I'm going to find d using our formula that we had on the previous part. That's this guy right here, right? The sequence difference divided by the position difference. So for this, that's going to be 67 minus 46, right? And then position difference is 22 minus 15, right? So 67 minus 46 is equal to 21, and 22 minus 15, that's 7. So you see d comes out to be 3, doesn't it, right? So now step 2, we come back and we get and we find a sub 1. So d works out to be 3. This must come out evenly. Actually, no, I'm sorry, that's completely wrong. D could come out, in this case it's coming out evenly, but it could come out to be a fraction or a decimal like we had on some of the earlier ones. In this case, it's a nice easy 3. Okay. So now, what's a sub 1 equal to? Well, we're going to use the general formula for arithmetic sequences. A sub 1 is equal to a sub 1 plus n minus 1 times d, right? Okay, so we can use either one of these two. Let's use that one. A sub 22. A22 would be 67 is equal to a1 plus 22 minus 1 times 3. right? So that's a sub 1 plus, what's that, 21 times 3, right? It's equal to 63, right? And then subtracting 63 from both is equal to 67. Subtracting 63 from both sides, a sub 1 has to be 4. Okay? So now, so the a sub 1 is now 4, and then that gives us our general formula, right? A sub n must be 4 plus n minus 1 times 3, right? Simplifying, that's 4 plus 3n minus 3, okay? And that works out to be 3n plus 1. So a sub n is equal to 3n plus 1. Checking our work to make sure that really does give us the terms in our sequence, right? We put 15 in for n, okay? 3 times 15 plus 1. 3 times 15 is 45, plus 1 is 46. Yeah, that's right. And 3 times 22 is 66, plus 1, indeed, just does give us 67. So that is the correct formula for our sequence. Okay, very good. Now, here's one. You try it. I'll put another one up here. You try it here, okay, using those formulas. So let's say that I happen to know that on a given sequence, the 8th term is equal to negative 53, right? And the 15th term is equal to negative 95. Be careful. So you try this one. This is example 3. This one's a little bit different because it's counting down. Okay? So see how that goes. Okay, and you're back. Okay? So let's see here. Step 1, we have to figure out what the common difference will be. Okay, remember we're trying to figure out a sub 1, d, and a sub n. That's what we're trying to figure out here, right? Okay, keep that in mind. So, we use our formula here. D is going to be equal to negative 95 minus negative 53. The later one in the sequence minus the earlier one in the sequence. It doesn't matter that that number is actually smaller. It's going to be smaller because the sequence is counting down, right? So the later one minus the earlier one minus the position difference, which was 15 minus 8. Okay, so calculator work here. Negative 95 minus negative 53. That's going to give us negative 42. And then 15 minus 8 is 7. Negative 42 divided by 7 is negative 6. So you see D comes out to be negative 6. Well, what does it mean for an arithmetic sequence to have a negative common difference? Well, that means you're counting down. In fact, kind of in more general terms, we're going to be subtracting 6 every time instead of adding 6 every time. Okay? Well, that's okay. So that was step 1, but you notice that works out the same way, don't it? Okay? So step 2, we're now going to figure out what a sub n is, right? So, or rather a sub 1. So, we got negative 6. Let's put that in. Now, we pick one of those two. It doesn't matter which. How about negative 95 for a sub n? So this is a sub 15, you understand, is going to be equal to a sub 1 plus n minus, or rather 15 minus 1 times whatever the d is, right? supposed to be 15 there. Sorry. Okay. So, a sub 15, that's negative 95. A sub 1, that's what we're trying to get to. 15 minus 1 is 14 times negative 6, right? So 14 times negative 6 is negative 84. So we've got negative 95 is equal to a sub 1 minus 84. Add 84 to both sides, right? And that's going to give us negative 11 is equal to a sub 1. So the first term in the sequence is negative 11. Okay? So that's up here. So what's our formula? That's our third step here, right? Remember, a sub n still equal to a sub 1, n minus 1 times d. So a sub n is equal to negative 11 plus n minus 1 times negative 6. Now we simplify that. Negative 11 minus 6n plus 6, right? And so that's going to give us negative 6n in the front. Negative 11 plus 6 minus 5. So that's a sub n. We're seeing negative 6n minus 5. And so that's a sub n up here. Negative 6n minus 5, right? Check our work. We should be able to get, if we put n is equal to 8n here, that should give us negative 53 as the 8th number. So yeah, negative 6 times 8 is negative 48 minus 5, negative 53. Perfect. Okay, so that's it. So that's 3 examples. And again, there'll be some classwork on this in a little while. And I'll post some classwork and you can try this out. And this will be on our homework too. All right, see ya. And then there'll be there'll be at least one more little video about arithmetic series and sums of series. Bye.